And now let me call Eliot Kerdreux. So you come from Neuroscience, and we started speaking about risk factors, and we moved on to very specific disorders. Now we are going to move back to disorders of neurodevelopment. So, Eliot, you are still a doctoral student, and you are working in David Germano's team in Paris-Saclay. So you are going to tell us about imaging and the subdimensioning of the deep gray matter and how this improves the diagnostic classification tools based on MRI in the ASD with fetal alcohol syndrome. And what are the disorders? It's the name that you give to neurodevelopment disorder based due to alcohol. So there is a syndromic form on which we have a certain number of characteristics that are associated, and it is the diagnosis is specific, and it is there is certainty with anomalies of the face morphology, with the height and weight, and of course with the lids, the eyelids, the lip to nose distance. So the diagnosis is easy to make because you have the characteristics that are present, but for the majority of these children, the characteristics are not present or not complete. So you need to look for other markers that are not immediately visible. So you have the neurofunctional phenotype. There are meta-analysis and studies of series of patients that with ADHD, intellectual development, intellectual deficiency, learning disabilities, frequency of the here 5% in our series of patients. It's the same case. So it's not the majority presentation. But in the first study, we looked at whether the IQ was a measure that really represents the capacities, the intellectual capacities in terms of reasoning of this population. So we first looked at whether the multiplication of cognitive alterations that would lead to a heterogeneity of profiles, but we didn't really find a difference significant. There was no significant difference here on the left with the sample, but still we were able to draw a cognitive profile with a tendency to alterations for the working memory and speed of performance. And then we looked at whether, depending on the score that you use to categorize the intellectual operation, what that gives on our series of patients, whether you use an overall measure, which is the IQ, or a measurement tool that looks more at the reasoning capacity, which is the IAG, or Index of General Aptitude, and subtests of psychometric tests. The best score on the tests for reasoning, and you see that a little more than 50% around 20% if we use the best subtest for reasoning. So in terms of the morphology of the brain, so brain is one of the favorite targets of toxicity of alcohol. Plus, these children who present a non-syndromic type will... So the morphology of the brain will be telling a tale that does not show on the face. And the idea is that we can maybe learn from the signature of the brain morphology on the persons who have a syndromic form and translate that onto those. The main criterion is the delayed growth or delayed brain growth or microcephaly, and this is the criterion that is taken in the diagnostic recommendations, but it does actually not really contribute. In literature, there are other focal anomalies, the cerebellum, the corpus callosum, and the structures in the middle of the brain. And in literature, the results are more or less consistent on the over impact on the Cody. And to explain these potential sources of variability, the idea is how do the studies make up their patient groups, and some of these studies will mix groups of patients who will have syndromic presentation or patients that are exposed or who have not received a diagnosis. So it's a mixed bag of presentations. And the smallest brain size, representation here of the volume, the regional volume, compared to the total brain volume. And we see that there is no overlap between the two. So this is something you have to take into account. And there is also the way we model this total reduction of brain volume. And the relationship is not linear. It's non-linear relationship. Proportions vary with the size. So if I take, for instance, two brains that have the same size, if I look at one peculiar specific region, they will not have the same volume. And then there is the question of the tools to do the neuroanatomical segmentations. Some tools are automatic, so there is a potential bias induced by the type of tool, and maybe sometimes even dependent on the person. Here you can have the segregation. It's the same tool, different versions. And in literature, there is almost no study that tried to use diagnostic classifications based on the MRI. There is this study by Little and Beaulieu, 2020, that showed that there are a certain number of regions that can contribute to diagnosis, but their aim is not to translate the signature in the syndromic form in the patients who have a syndromic presentation. But there is this study by my colleague Fraze, who tried to get a diagnostic classification, a classifier train, in the alterations to the cerebellum, and if we apply this to patients who have a syndromic presentation, so what you try to do in this study is to characterize the profile of subdimensioning of the deep gray matter, trying to segregate between the syndromic and non-syndromic patients, and trying to use a non-linear model and by comparing the different tools for neuroanatomical segmentation. And then we tried to translate this profile in a profile of alterations in the patients with a syndromic presentation, and translate that into the patients who have a non-syndromic presentation to see if there was a profile compatible with the syndrome. And so for this study, we used the cohort that is monitored at Robert Debré Hospital, 37 patients with 53 patients with syndromic and 37 without. And in terms of the diagnostic procedure, we tested the concordance between two international recommendations that are the most used. So there was a high concordance in our sample. And also systematically, we had differential diagnosis explorations, systematic MRI, genetic explorations, and biological markers, and also segmentation of the MRI images to have the caudate globus pallidus, the thalamin. And here we see that the totals of brain volume, we have adjusted a law of power to take into account this nonlinear relationship between the two volumes. By testing, if you have this equation, if small a is equal to 1, if small a is different, we talk about isometry or allometry. And here we have patients versus control, and we measured for each subject the deviation, that is the distance in regard to the law of controls, by looking at the interval in which we expect to find our patients, taking into account their small brain. In our controls, we don't have subjects because the controls do not have microcephaly. So this individual deviation enables us to extrapolate an average. To have over dimension or under dimension. We reproduced step 1 and 2 using two tools to compare the robustness of our results. And then at a fourth stage, we created a diagnostic classifier, which is a linear logistic model. We got the neuroanatomical parameters, the reduction, the microcephaly, the size of the brain, the dimensioning of the deep gray matter, and the profile. And the classifier was trained on a group of patients with a syndromic profile. And then we applied it to a group of patients with a form that is non-syndromic to try to identify if a group was presenting a signature that is compatible with the disease. Okay, now let's look at the results here. The scaling curve that I will show. The volume of gray, deep gray matter. So there is a disturbance of the typical relationship. So we saw that the curve was isometric and nonlinear with the control group. Isometric in the patients in one group and nonlinear with the other group. And from this disturbance, we calculated an average deviation minus 12%, 0.6% in the in the patients that had a syndromic presentation, and minus 9% for the ones with A0 here corresponds to no over-reduction for the accumbens. The blue corresponds to an over-reduction intermediary for the thalamus and putamen, and the pink, which represents a important reduction for the globus pallidus. In regard to the comparison of our results, the profile of based on the segmentation tool, we see that there is a difference in the. But in spite of those differences, that concern really the magnitude or the magnitude of this over reduction, depending on the tool, we're able to find a convergence depending on the tool of. So when looking at the classifier, what we show is that the information, when we build a diagnostic classifier just based on the classifier enables us to identify 50% of patients with a non-syndromic presentation. And when we add heterogeneity of the impact on the central, but when we test on the non-syndromic, we have a non-significant increase. But the interesting thing was that we have a classifier based on the microcephaly, which is the only criterion used in the international recommendations, which is very frequent in our patients. 70% of subjects correctly identified, and when you add the information that is information from the deep gray matter, we increase that. The interesting thing is that when you apply that to the patients with a non-syndromic presentation, you see an increase in the number of patients identified as having a signature compatible with the syndrome of fetal alcohol abuse. But these subjects did not present microcephaly. So in this study, we showed that in the fetal alcohol use, there is a differential impact depending on the area considered in the brain, and this was something that has not been looked at before. And what we showed is that when we integrate this information in a diagnostic classifier based on microcephaly, this profile of alteration of the deep gray matter will improve the performance of the classifier and enable us to identify patients. 30% of the patients without microcephaly, but we're still correctly identified with this signature. So the limit is that we have not yet demonstrated that these markers are specific to the fetal alcohol syndrome. We compared with subjects with typical development, but we would need to be able to demonstrate that with comparable cohorts. Another limit is that we did not have the statistical power to get a classifier that would discriminate based on sex, and I think there is this former study, 2022, Little and Beaulieu, that shows that regarding brain size, the brain regions that contribute the most to the diagnosis are not the same if you have girls versus boys. So what we would like to do is that we would like to show a gradient in the cerebellum. We have works, we have papers that show markers on radioclinical measures or markers of the colosal markers, and we would like to combine all of these markers to train a whole brain classifier. We think that by combining all of these markers, we will be able to increase the specificity of our diagnostic tool, and we would like to know what it says about the operation and the prognosis for these children. What we would like to know is very basically to have correlations between anatomy and function in their cognitive profile. Thank you for your attention. Thank you, Eliot. I suggest we don't go for the questions and we move to the round table. That's not your fault because you were exactly within your timing. So thank you very much for that. So you quoted the Vivre Association.